Okay, my friends, so you can see my screen, and today we are going to focus on the comprehensions concepts and the list and set and dictionary comprehensions, how they can be implemented in Python and for what purpose. We are going to analyze that, and we are going to cover while loops in later part of our course. So let's focus on list comprehensions. So far we have covered the for loops, right? What is the main logic of a for loop? So let's go back a few slides. We have said that in a for loop in Python, there is an assignment target that is the driving force of the for loops. That's just a variable. And the variable will be associated with values in an iterable object, such as a list or a tuple or a range or string or a set or frozen set or dictionary. Okay, so this iterable object contains a sequence of elements which may or may not be subscriptable, but definitely iterable. And in the for loop, the target variable will be associated with each of these elements in the iterable object. Then we have a colon sign here, which is a important semantics for a for loop. After the colon sign, we have an indented code block, which may consist of multiple command lines. That code block is going to be repeated again and again and again until the assignment target will be associated with each element in the iterable list. During the code block, the target variable may be a part of the code block or may not be part of the code block. In any way, the total number of repetitions of the code block is equal to the size of the iterable object. Okay, so in a for loop, we know how many times the repetition of the code block will occur. So it is basically a deterministic number of times that the code block will be repeated. Now, what is comprehension then? Is it different than for loop? My friends, definitely different than for loop, but it uses for loops in it. Okay, in comprehensions, we are using for loops to create a certain object. Okay, now in general, for loops are not necessarily used for creating a certain object. Okay, we may, in a for loop, we may concurrently update a certain object, but we may not create an object. However, the name gives it away. It says list comprehension. What does that mean? Actually, we are creating a list here. Okay, we are not running just a for loop. We are creating a list here, and we are using for loops to create that list. Okay, so a list comprehension is a method to create a new list in which each element is the result of applying a given operation to a value from an iterable object. So when you look at this picture here, you will understand what I mean. In a list comprehension, you are just creating a list. Therefore, the comprehension should be written inside the square brackets. Remember, we were using square brackets to create list objects. Again, we are opening and closing a square bracket so that we are creating a list in the end of this list object. A list comprehension, and you may even assign the list that is going to be created to a certain variable, which we are going to see later in our applications. Okay, so inside the list comprehension, you write a for loop. Okay, but in a single command line. Okay, in one command line, we are writing the for loop. Here, this is how it works. So we define a mapping of the assignment target, which will be corresponding to shape of the output, shape of the elements in the output list. The mapping will convert to target. So this mapping must be a function of the assignment target, my friends. Okay, and we say that apply mapping for the target variable, where the target variable is going to take consecutively values from the iterable object. Okay, so in a simple list comprehension, we have two keywords, for and in here. Before the for keyword, we write the mapping of the target. After for, we write the target variable's name, and then we write in keyword, and we write in which iterable object that assignment target is going to be associated with the values So this is how we apply the list comprehension. And this is the simplest list comprehension that we can apply and we can understand in this practice. So this is the first example about list comprehension. So let's see, what does it do? We want to create a list of squared values, okay? Squared values. So we say that squares is a list which is created by a list comprehension. The mapping of the assignment target is square function. So we say that n is my assignment targets. We will create a list of the squares of the n values, n to the power 2. Then we write the keyword for, and after the keyword for, we write the name of the assignment target. As you can see, on the right-hand side of the for keyword, we have the assignment target, and on the left-hand side, we have a projection or a mapping of it, which is basically a transformation of the assignment target in some sense. Then we say that this assignment target will take values in the range object, in a range object, which is a list of consecutive, a tuple of consecutive integers from 0 to 10, okay? Because we have built this range object up to 11. We have only passed a single argument, which is 11, which means the range object will contain integers from 0 to 10. Then we print this squares list. And as you can see, from 0 to 10, we are only seeing the squares of these integers, okay? So basically, a list comprehension is not a for loop. It utilizes for loop to create a list, okay? Therefore, it is called a list comprehension. Therefore, this is not a looping mechanism. This is not just a sole looping mechanism. It is a mechanism that creates a certain object, okay? Remember, again, in for loops, we are not necessarily to create a certain object. We can simply perform a certain operation, deterministic number of times, but here we are basically creating a list, okay? List comprehensions are not very easy to understand, or any other type of comprehensions that we are going to cover today. Now we know that, isn't it possible, we can ask this question, isn't it possible to create this square list using a for loop? Yes, it is. Actually, we can create this squares list by using a for loop. However, my friends, list comprehensions, dictionary comprehensions, and set comprehensions are commonly used in advanced, in between advanced programmers. Therefore, it is a good idea to understand how they work too. However, if it is going to make your life easier, there is no harm to create this squares list by using a direct for loop instead of a list comprehension, okay? You are obviously responsible about learning this kind of comprehensions. That does not mean that, I mean, the fact that you are not obliged to use comprehensions in your homeworks or exams, that does not mean that you shouldn't be understanding how they work. So before moving further, let's see in practice, okay? So this is my list comprehension program, as you have seen from the presentation file. So we say squares is a list which is created by mapping the assignment target into square transformation. And the assignment target is just going to take values of integers from 0 to 10. And when I print squares, obviously I will see the squared values from 0 to 10, which are going to be 0, 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Okay. Now, it is also possible to add a Boolean expression and an if statement in a list comprehension as the third part of the list comprehension. So after defining the mapping for the assignment target and defining the iterable object on which the assignment target will be associated with the values, you write a third keyword, which is the if keyword. Then you write a Boolean expression. Now, the target will be associated with the values in the iterable object. However, the mapping will only be calculated if this Boolean expression is satisfied for the current assignment to the assignment target. Okay. If the Boolean expression is true, then we are going to add the mapping into the list. If the Boolean expression is false, then the mapping will not be added to the list. So let's see how this works. I create a tuple here. Remember, a tuple is also an iterable object. Therefore, when you intend to create a list comprehension, the iterable object that you can use can as well be a tuple object. This tuple object contains the codes of the course that most of you are taking in the semester: 201, 212, 216, and 246. Okay, there are 4 elements in this tuple object, and I say I want to create a square roots list. Okay, a square roots list, and my assignment target n here after the for keyword is going to take values one by one in my tuple object, which is the iterable object here. And what we are going to do is we are going to take the square root. We are going to take the square root of each value, okay? And we are rounding it to 4 decimal digits, okay? This is the mapping that we are going to use today. So, however, there is also an if keyword in the end of the list comprehension. It says after the if comprehension, n mod 3 must be equal to 0, which means the list comprehension will be created by the values in the iterable if these values are integer divisible to 3. Okay, integer divisible to 3, which means here it says n mod 3 being equal to 0 means what? Basically n to be integer divisible without a remainder term, integer divisible to value of 3. So if these values are 3 or multiples of 3, okay, the contents of the tuple object are multiples of 3, then the list comprehension will map them into the rounded version of their square roots and create the list out of them. However, if they are not integer divisible to 3, they will not be included in the list comprehension. Now, please check 201 is integer divisible to 3. 216 is integer divisible to 3. 246 is also integer divisible to 3, but 212 is not integer divisible to 3. Therefore, the mapping for 212 will not be created. Therefore, it will not be included in the list that is created out of this list comprehension. When you print the square roots list here, you will see the square root of 201. You will see the square root of 216. 246, but you do not see the square root of 2112 in this list comprehension, my friends. Okay. Did you understand this? Did you understand how the list comprehensions with if statements work? Yes or no, please.
Yes, hocam.
Okay, you are following me. Now, my friends, it is also possible to create a list comprehension with multiple assignment targets. Okay, we can use multiple assignment targets to create. In fact, you can run a for loop with multiple assignment targets, which we have done only in iterating over dictionaries. So let me show that to you previously. So remember, we have said that it is possible to iterate over the items object that is created out of the list, okay, the items object. Remember, when you apply the items method on a dictionary, you are just going to have 2 element tuples in each element of this tuple-like object, okay? So there will be, the size of these items object will be 3, okay? There will be 3 keyword couples, but these keyword couples will be given in the form of a tuple. Therefore, K will be associated with the first element, 0 index of the tuple, and V will be associated with the first index of the tuple in the elements, as the elements of these items object. So it's a tuple-like object, but not necessarily a tuple, because the items objects are not too subscriptable. They are not subscriptable, but they are iterable. Therefore, it is possible to create for loops by using multiple assignment targets, and it is also possible to do that in list comprehension. So let's see how this works. So we say faces. Faces is a list. It is a range object that starts at 1 and terminates before 7. Therefore, faces is a range object that contains integers from 1 to 6. Okay, 1, 2, 3, 4, 5, 6. Okay, which basically gives us the outcomes of a regular diatrope. Now, my objective is this. I want to create a list that contains all possible outcomes of the experiment in which we toss 2 dice. Okay, so these outcomes are as follows: 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 4, 2, 6, so and so forth. It goes like this until 6, 6. Okay, there are 36 possible outcomes when you toss 2 regular dice. Now we want to create a list like this. Please look at this list. In this list, we have 36 elements, but each element is a 2-element tuple. Each element is a 2-element tuple. So we say, I want to create a list of outcomes which will map X and Y into a 2-element tuple like this. Remember, we create tuples using ordinary parentheses, and there's a comma in between. So this is a 2-element tuple. And we say for X in faces, empty space for Y in faces. My friends, you are not supposed to write the next for loop in the next command line. You can also write it in the first command line, okay, after just leaving an empty space, a space break. However, since I want to comment here with this and I want to show that comment, I haven't done it like that. So let's see how this works in Spider, okay? So please check that out. So I say X is going to take values in the faces range, and Y is also going to take values in faces range. So there are 2 for loop definitions in this list comprehensions, but there's a single mapping which will be running over both for loops. Okay, so let's go back. So let's write this to the first command line. So as you can see, it will still work. So it says that X is going to take values in faces. For each value that X takes in faces, Y is also going to take all 6 values in faces. So this for loop is basically a nested kind of for loop. It is a nested for loop, which will iterate for 36 times. The first for loop will iterate 6 times. For each iteration, for each repetition of the first for loop, the inner for loop will repeat 6 times. Therefore, when you check the outcome, in the outcome, you see that in the first 6 elements, X is associated with 1 and Y is changed from 1 to 6. Then the outer loop enters into its second iteration. The X variable will be bounded to 2 this time, and the Y value will be bounded to consecutively 1, 2, 3, 4, 5, and 6, so and so forth. So basically, this is kind of a for loop that is nested, nested in each other. However, the mapping is defined only once. So you define one mapping here, which is a 2-element tuple of X and Y. So you can get the outcomes in a list of a 2 regular dice draw. Okay, so I am, as I have told you, that I am writing this into the next command line so we can see the comment here in the end. It does not make any difference. Okay, instead of using a space break here, you may as well use a new line. Still, the list comprehension will work. But remember, now the objective of a list comprehension is what? To, instead of using 2 nested for loops in multiple command lines, we want to create this list object in a shortest possible command line, which is a list comprehension. Okay, the shortest possible way to create such a list is to use a list comprehension. Okay. All right. So it is also mentioned in the presentation file. I am not writing the second for loop here in the next command line because it's a syntactical requirement. It is not required. But I mean, if you want to enhance the readability, so and you want to understand which for loop is the inner for loop and which for loop is the outer for loop, you can basically do and create this list comprehension like this. All right, so let's do this again. This time, I want to create a similar list object which contains the outcomes of the toss of two regular dice. However, I also add an if condition in the end of the list comprehension. So if you are running a list comprehension with multiple assignment targets, or instead, in another words, if you are applying a nested structure of for loops in a list comprehension, that does not mean you cannot use Boolean expressions. Now I am adding a Boolean expression after the if keyword here. I say that include xy tuple if y is greater than 2. If the outcome of the second die toss is greater than the first die toss, then it will be included in the outcomes list. However, otherwise, if the outcomes are equal or the first outcome of the first die toss is less than the outcome of the second die toss, in that case, the outcome will not be included. And when you apply it like that, as you can see, a list object will be created containing two element tuples, and it is just going to contain 15 elements in it. And as you can see, the common property of these 15 elements are what? The first element, the zero index element in the tuples are always less than the second element. Okay, so you can also apply a Boolean expression in a nested structure of list comprehensions. Okay, now this is not actually a nested list comprehension. This is called a list comprehension in which the for loops are nested. Okay, so we are basically creating a list of tuples here. Okay, a list of tuples. But we can also nest list comprehensions one inside each other. Okay, this is going to be something different. So my friends, remember the previous example that I have covered on Thursday. We had two tuples here, which respectively represents the horizontal and the vertical coordinates of locations, 6 locations in a map. And we have used two nested for loops here to create a distance table, which was basically a nested list. In this nested list, there were 6 elements. Each element is a 6-element list again, and it was representing a distance table, or in other words, distance matrix. So the first row here, the first nested list here, represents the distances of the location 0 to location 0, location 1, location 2, location 3, location 4, and location 5. The second list that is nested in the outer list represents the distance of the first location to the 0 location, first location, second, third, fourth, and fifth locations, so on and so forth. Now, our objective is this. So instead of using this nested for loop mechanism in here, which basically is creating 5, which is created in 5 command lines, we will check if this is possible to do it in a nested list comprehension. Okay, and it is possible actually, my friends. Okay, we can write a single nested list comprehension to create such a distance table instead of using nested for loops. But remember again, you are not supposed to, in your homeworks, in your exams, you are not supposed to, if you are free to write your program as you like, you are not supposed to create such complex list comprehensions. However, if I ask you a question related to a list comprehensions, you should be able to answer it. Okay, so best way is this. I mean, try to, I mean, if you want to understand the list comprehensions, you should try to write the list comprehensions as much as possible. But if it is just going to make your life easier, not necessary. If you are not forced, if you are not asked to create a list comprehension, then you can do this in the ordinary way by using for loops, which is just going to be much easier for you. Okay, again, we have the same horizontal coordinates for the 6 cities from 0 to 5, and the vertical coordinates of these 6 cities from 0 to 5. And the number of cities that we have is equal to the length of the x tuple, which is 6. Now I say create a distance table, which is the outcome of a nested list comprehension. And please check that nested list comprehension. We have a list comprehension created by a square brackets, the first square bracket, which ends in the end of this command line. Okay, I say my list comprehension will create another list comprehension. My list comprehension will create another list comprehension. So for the first list comprehension, the mapping is a second list comprehension. Okay, the mapping is not creating a 2-element tuple, or it's not calculating the square. The mapping here is creating another list comprehension for the assignment target I, taking values in range object that starts at 0 and ends before n. Okay, so this is basic. This range object for n being equal to 6. This range object is containing integers from 0 to 5. Now, the mapping is another list comprehension. In the second list comprehension, the assignment target is j, and it is also taking values in the range object, integers from 0 to 5. And in the inner list comprehension, nested list comprehension, the mapping is a rounded version up to 4 decimal digits, rounded version of the Euclidean distance formulation. So you remember the Euclidean distance formulation, the square of the difference between the horizontal axes, the square of the differences between vertical axes summed up, and the summation is taken for the square root. And this is basically calculating the Euclidean distance. So my inner mapping is an Euclidean distance. However, the outer list comprehension will create lists that contain these Euclidean distances. Again, for the city 0, we will create a list of Euclidean distances from 0 to 0 city, first city, second city, third city, fourth city, and fifth city, so on and so forth. Then the outer list comprehension will iterate over I, and I will become 1. For the first city, again, we will calculate the distances to city 0, city 1, city 2, city 3, city 4, and city 5, and embed these distances inside the inner list. And as you can see, this nested list comprehension is creating a nested list. Okay, a nested list here. And then, my friends, please check. Remember, in my previous application on Thursday, I was also running another for loop here for a given route. So this is my given route that starts at 0. I will visit cities 0, 3, 5, 2, 4, 1, and I will come back to 0. I'm interested in calculating the total distance that I am going to travel when I visit this route, when I visit these cities on this route, starting from 0 and ending at 0. Now, by the way, this is a very practical application, especially in operations research problems related to logistics, okay, logistics services. So it is a good idea for you to understand that kind of distance calculation for a given route, because in most of the applications that you are going to develop, you are going to solve these kind of route calculations if it is related to logistics operations or a network optimization problem. Okay, so let's go back. Now I have created my distance table by using a nested list comprehension. Now I am given the same route here, and I am creating actually a list comprehension again. Okay, a list comprehension. In this list comprehension, I will basically calculate the distances from 0 to 3, 3 to 5, 5 to 2, 4, 4, 1, and 1, 0. Basically, over that route, each arrow or each arc that I am going to follow, for them, I will calculate the distances, and these distances will be written in a list comprehension. Okay, so in this route, how many arcs that I'm going to follow? 1, 2, 3, 4, 5, and 6. So I will visit 6 cities, and since I am going to come back to origin point, which is 0, I will be visiting 6 cities, my friends. Okay, I'm sorry, I will be following 6 arcs. Okay, basically in this list comprehension, I am going to calculate the distances of these arcs. Okay, the lengths of these arcs. So this list comprehension is not a nested list comprehension. It's just an ordinary list comprehension. I say the assignment target I will be taking values in a range object, which starts at 0 and terminates before length of the route -1. Now, please check the length of route is 7. 7 minus is 1. 7 minus 1 is 6. Therefore, this range object will iterate over integers from 0 to 5. Okay, so from 0 to 5, starting at index 0, it will basically be calculating the distance from the 0th element of the route tuple to the first element of the route tuple. So in its first repetition, it will calculate the distance from 0 to 3 by using the distance tab. It will not be calculating it. It will be just pulling that data from the distance table that I have created. Then in the second repetition, as assignment target here takes the value of 1, it will be identifying the first element of the route and the second element of the route, and it will take the distance from distance table from city 3 to city 5, so and so forth, and it will go like this. It will be creating, this arcdist will be creating a list of the direct distances between each consecutive city in this route. Okay, there will be 6 direct distances in this arcdist list. Then I will simply take the sum of it. Okay, when I take the sum of these direct distances, their sum will give me the total distance that I am going to be traveling over my route, and I will write it in a F string, where my placeholders will contain the route for which I'm calculating the total distance. And in this placeholder, I write the total route length rounded to 4 decimal digits, which is 28.6236 again. Okay, so let's see this list comprehension again in practice. Okay, it works like this. Let me show you. Okay, let me show you the arc lists that I am creating here also. Okay, so as you can see, this list here contains the direct distances from 0 to 3, 3 to 5, 5 to 2, 2 to 4, 4 to 1, and 1 to 0. You can in fact check them from the distance table that you have created. Everything works just fine. Okay, any questions, my friends, up to here before moving on set comprehensions and dictionary comprehensions? If you have any questions, please ask. Are you okay? Yes or no, please, so I can understand you are following me.
Yes, hocam.
Yes, hocam.
Okay, thank you. Now I will follow with the set comprehensions. Now, what do you think a set comprehension is? Again, it is using a for loop mechanism, but this time for creating a set. Okay, it is almost the same as a list comprehension, except by definition, the created set can only contain unique objects, which means if you apply a set comprehension, the only difference is this, please check, the only imperceptible difference. Okay, so we have curly brackets outside the comprehension here. Again, we have the same sequence of command lines. We define the mapping for an assignment target, and we define the assignment target will be taking values in the iterable object. And if we want, we can write a Boolean expression. If and only if the Boolean expression is true, then the mapping will be created and it will be added in the set that is going to be created. So this set comprehension is also creating a set. Okay. The only thing here is this, the difference, the basic difference. if a mapping of a value that the assignment target takes is included in that set, and for another value of the assignment target, we get the same mapping, that will not be included because it has been included at least once, okay? So in the definition of a set, we know that the sets have unique elements, okay, unique objects in it. If more than one value in the iterable object creates a mapping which are the same, now only one of these mappings will be included. Therefore, you can consider this a kind of Boolean expression. If it is already in the mapping, if a mapping, the same value is already added in the set, it will not be added again. Therefore, set comprehensions are not very hard to understand once you understand the list comprehensions. So here we are going to do something different, my friends. There's a function here, which is a quadratic function, x squared minus 19x plus 70. And we are restricting the domain of this function to integers from 0 to 20, which means actually this function can be evaluated for any real number. You can just plug in any real number that you like in place of x. So you are just going to end up with another real number. However, for this practical application, I say that this function is only defined over integers from 0 to 20, and I want to see the domain. Okay, sorry, this is the domain of my function. I want to see the codomain of this function, the set of destinations. Okay, so you know the domain and the codomain concept from calculus. The domain of a function is the domain in which the function is defined, which means the x can only take the values from the domain, okay? And the codomain is what? Is the set that is created by the reflected values. So for all values of the domain, you evaluate the function and you contain the responses in another set, which is called the codomain, okay? Türkçe'de bunu nasıl değerlendiriyoruz? Girdi kümesi, görüntü kümesi gibi bir şeyler söylüyorduk yani. So domain and codomain are like this, okay? So the domain is the set of input values, codomain is the set of output values with respect to the domain. Now, as you can see, from 0 to 20 for all integers when we evaluate this function, the values are here. But as you can see, for the input 9 and 10, you get the same output. For input 8 and 11, you get the same output. Now I can create the codomain with a list comprehension easily. However, I do not want to get the output list. I want to get the set of that represents the codomain of this function. So I will use what? I will use set comprehension here. So please check. I say my domain is a set that is obtained by the transformation of a range object that starts from 0 and terminates with 21. So basically, this set contains integers from 0 to 20. When I print the domain, you will see a set that contains integers from 0 to 20, and in an increasing order, by the way, by surprise. Remember, sets do not have any order in it. The objects are not ordered in a set, but it is not changing the original order which are given in the range object. It is just giving us the elements in the original order from 0 to 20. Now I will create the codomain by using a set comprehension. My mapping is n squared minus 19n plus 70. I say n, the input n, the assignment target n, will be taking values in the domain set. So n will be iterated over the domain set, and for each iteration, the output will be evaluated and it will be entered in the codomain set. As you can see, minus 20, minus 18, which were previously repeated in my previous representation, are only included once in the codomain. So even the domain has 21 inputs, the codomain has only a smaller number of inputs here, which is basically 11, okay? So this is the only difference. Now I can also introduce a Boolean expression in the end of the set comprehension here. I can say that, again, create the codomain for all input values from 0 to 20. However, add the value into the codomain if the absolute value of the evaluated value is less than or equal to 15. Okay, if it is less than or equal to 15. Please check. These values will be added only once if and only if they are less than or equal to 15. Okay, so this means what? The codomain will only include this time 10, 0, minus 8, minus 14, minus 18, minus 20. It says less than or equal to 15. Sorry, absolute value of the result. Sorry, absolute value of the result. Therefore, it says it will be containing 10, 0, minus 8, minus 14, and that's it. Okay, only 4 of these values, because the other positive values are greater than 15, and the other negative values, absolute values, are greater than or equal to greater than 15. Therefore, the codomain that is truncated, I call this a truncated codomain because I am truncating it with respect to a Boolean expression, will only contain the responses which have an absolute value that is less than or equal to 15. Okay. Did you understand the set comprehensions, my friends? Yes or no, please?
Yes, hocam.
Then moving with the dictionary comprehensions. Now, as you can see, comprehensions can be used to create lists, sets, and dictionaries, which are the mutable objects that we have learned so far, right? So mutable objects, lists, sets, and dictionaries can be created by using comprehension structures. However, that does not mean that all lists that you want to create can be constructed like that, okay? Only if the contents of the comprehensions, contents of a list, contents of a set, or contents of a dictionary can be defined through a regular structure out of a for loop, then they can be created by using comprehensions, okay? Now, in the dictionary comprehension, my friends, again, you are using curly brackets, okay? Remember, in the set comprehensions, we were using curly brackets to create set comprehensions. Again, you need to use curly brackets. However, the difference is what? The mapping here will be a key value pair, okay? There will be an assignment target here. It can be a single target or 2 targets. It doesn't matter, okay? Multiple targets or single target. There will be an assignment target here, and there will be an iterable object here, okay? An iterable object here, and you can also add a Boolean expression, okay? This means the assignment target will be associated with every single value in the iterable object one by one, and if the Boolean expression associated with that value of the iterable object is satisfied, a key value pair, which is created as a mapping, okay, which will be created as a mapping of the assignment target, will be added to the dictionary. That is the output of this comprehension. So let's do it. I want to create a square dictionary as previously, in which the keys will be integers from 0 to 9, and the values will be the squares of these keys, okay? So I say, create a square dictionary by using curly brackets. I say my assignment target n will be associated with the values in a range object, which contains integers from 0 to 9, and the added key value pair will be n colon n square. Okay, n colon n square. So it is just like built like a set comprehension. The only difference that makes this a dictionary comprehension is that the mapping is in the form of a key value pair, where we have a colon sign in between the key and the value. Okay. Now, as you can see, this simple program creates the dictionary object that as I have intended. However, I can also apply a Boolean expression in the end of the dictionary comprehension by an if statement. So it says, add the key value pair into your dictionary if the assignment target is equal to do square of the assignment target mod 10. What does that mean? What does that mean? So you calculate the square of an assignment target, then you divide it to 10 and calculate the remainder term. Okay, calculate the remainder term. And if the remainder term itself is also equal to n itself, in that case, that key value pair will be added to square dictionary. For example, let's check for 0. 0 square is 0, 0 mod 10 is 0, therefore 0 is equal to 0. Therefore 0, 0 key value pair is added. For 1, 1 square is 1, 1 mod 10 is 1, 1 is equal to 1, therefore 1, 1 pair is added. Now let's check 2. 2 square is 4, 4 mod 10 is 4, unfortunately 4 is not equal to 2, therefore it is not added. So let's check 5. 5 to the power 2 is 25. 25 mod 10 is 5. 5 is equal to 5. Therefore, 525 is added. Similarly, 6 to 36 is added. However, 749 is not added. Please check which key value pairs are added here. Only the ones in which the key value pair has the last elements equal to each other. For example, 5 and 5. 6 and 6 here. 7, 9, it doesn't work. 8, 4, it doesn't work. Did you understand this? Though these expressions seem to be a little bit complicated, it is once you know about the infix operators and the Boolean expressions that you are creating, it is very easy to understand. Did you understand why the second square dictionary only contained these elements? Yes or no, please?
Yes, hocam.
Yes.
Yes, you are fine. Okay. Now, there is one more application which is important, my friends, and which was related to your first homework assignment. Actually, in your first homework assignment, if you knew this, the first question would be much easier for you, but I mean, it would be again possible to solve the first question with your current knowledge up to that point. Therefore, there is no harm. There was no harm in asking it. Now, remember, I can use dictionaries to express functions, right? Functions. If these functions are invertible, which means if these functions are one-to-one functions, obviously this is not the case. Okay, this is not a one-to-one function because both 9 and 10 are having their reflections, projections in the codomain same. Therefore, this is not an invertible function. However, if you are, if you have created a dictionary with key value pairs that are one-to-one related with each other, okay? In that case, you can invert that dictionary, which means you can create a dictionary where the keys in the original dictionary are values and the values in the original dictionary are the respective keys, okay? So in some cases, it is quite natural to create dictionaries like this if there's a one-to-one relationship between the key value couples, okay? So imagine we are creating a dictionary with a dictionary comprehension, which is going to give us the squares of integers, okay? But for non-negative integers, because for negative integers as well, we can get the same outputs here. For only non-negative integer n, we are creating a square dictionary, okay? Then we want to create an inverted dictionary object, which is called the square root dictionary, okay? So please check the output. Please check the output here. So the first dictionary is the square dictionary, 0, 0, 1, 1, 2, 4, 3, 9, 4, 16. It goes like this. And the second dictionary is the inverse of the first dictionary, which is the square root dictionary. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. 9 is 3. 16 is 4. So this is just inverted dictionary, okay? So how do I create that? So let's just say I have already created a square dictionary using a square dictionary comprehension here. And now I want to create another dictionary which is containing the square root dictionary, square roots. I call this square root dictionary 1. I create it as an empty dictionary, my friends, because I am just going to invert it. I am going to invert it into an ordinary for loop. Okay, I'm not going to use this dictionary comprehension to invert it. I'm just going to use an ordinary for loop. Okay, so I say for key and value, so key and v here are just variable names, but I will call them key and value. For key and value in square dict items, remember we can iterate over the object that is created by the items method on a dictionary object. So each element of this object will be 2 element tuples. K will be associated with the 0 index, v will be associated with the first index. Then I say square root dictionary once value will be equal to key. Okay, so I am basically storing key value pairs in key and v variables, but when I create the inverse dictionary for the key v, I store the value key. Okay, this is how this is one way to create the inverse dictionary, my friends. And when I print that, you will get the exactly inverse dictionary here. Okay, but it is handled by an ordinary for loop. Now it is much more easier to handle it with a dictionary comprehension, my friends. So I say my second square root dictionary is obtained by a dictionary comprehension where the assignment targets are key and v, which are taking values in the items method applied on the square dictionary. And I am basically creating my mapping by swapping the positions of key and v. Okay, so I say create a dictionary object, which is a mapping of key and v as v and key, okay, with a colon sign in between them. And key and v will respectively be the keys and values in my items object, my friends. Okay, are we good? Did you understand this second example? Did you find it easier? Honestly speaking.
Yes, hocam.
You are
Yes.
fine, right? Okay, I'm just going to stop recording right now for the first hour.